Yo, welcome back. You're watching J2ME in 2025. So, last time we did a basic development environment setup. In this video, let's cover up some theoretical background behind game development and explore some basic J2ME APIs. And we're gonna start with a very important concept as games are made of frames. Now, what are frames, you may ask? So frames are nothing but slices of an animation. When you draw frames continuously, it creates the effect of an animation. As you can see, here we have 6 frames, which together create this bouncing ball animation. And in this case, each frame is a distinct image that defines the current position of the ball, and when we loop over them continuously, you would be getting something like this, where the ball is jumping slower on the upper animation because it's running at 10 hertz frame per second. So that means basically it's spinning 10 frames per second, right? And in the bottom half you can see the animation that is based on 20 fps or 20 hertz fps, which means you are now drawing 20 frames per second. When you draw 20 frames per second, each frame takes about 0.05 seconds to be drawn. That is represented by the delta time. So these are the common terms you would be encountering when developing games, is delta time and frames per second. And in order to give a smooth experience for your players, you must try to render everything at a constant FPS. Usually we choose 30 FPS or 60 FPS, but in some low power devices it's better to get down to around 15 to 20 FPS, as you can see. And there's also one more issue related to the device speed, where faster devices may be rendering the same animation at faster speeds at more FPS, but the slower devices might be drawing them at a much slower rate. So there are techniques to control this rate at which we are drawing the frames, and we'll be exploring that in an upcoming videos, not in this one, but yeah. So next thing we need to know is how to draw a frame. So a frame is just an image. So how do you draw an image? The answer is quite simple. Using a canvas. As you can see, the Japanese have been drawing the same red ball on a white canvas for centuries now. And we have something similar in terms of APIs. Usually the platforms come with a canvas APIs. Now, canvas APIs help you draw graphics while abstracting away the hardware details. Means you do not need to worry about the CPU, GPU, or the screen settings of the user, and go on with drawing primitive shapes and other graphical things without worrying about the hardware. Now, some popular examples include the canvas element that's provided in HTML5, or there's also a canvas class in Android that you can use to draw things. Using a canvas in J2ME is simple as well, because J2ME comes with its own canvas implementations. So the first one is the LCD UI canvas, which is a basic canvas that provides you APIs for drawing graphics and handling input events. And there's also a specialized subclass called the game canvas that is designed for game development, and it extends the Canvas APIs with an off-screen graphics buffer and multi-key input handling. What that means is it'll be able to handle simultaneous key press events and such, which is generally helpful for game development because it will be making lesser calls for checking which key has been pressed or not. And we'll explore these in upcoming videos as well. But now is the time for a code demo. So these are the steps that we'll be covering. We'll be making a new Gradle subproject and have basic setup for the metadata of our apps, and then we will be creating an entry point which extends the midlet class provided by J2ME. In the third step, we will be creating a custom canvas instance, and that will draw certain shapes for us. And finally, we will be displaying that canvas on the screen and checking out the results. All right, so let's jump right into the code. We have IntelliJ opened up. Now, to create a new Gradle project, you have to follow these steps. So every Gradle project will reside in its own subfolder. So let's create a subfolder named red ball, right? And this will have all the sources for us. Now, to identify it as a Gradle project, you need to create a build.gradle.kts file inside it. So let's do that. This is your build script that will contain all configuration and metadata for your jar files. Now, the first thing you need to do is to apply the J2ME apps plugin. This is a local plugin that also resides within this repository, and it will help detect this Gradle subproject as a J2ME app and add some necessary tasks for it. Now, one more step is to add this inside your settings.gradle file to include it in your build. And this should ideally help Gradle identify the project. So once Gradle and IntelliJ have detected this project, you should be able to get syntax highlighting in your build script. Here we are going to configure the jar task. Now, this will add some metadata to our final jar. We're gonna do this step first so that later on we can focus purely on the code side. So upon adding this manifest block inside the jar configuration, you can add certain key values to help detect this as a standard J2ME app. So the first key we would be adding is the midlet 1. Now this takes in a string with the first value being your app name, the second being a path to your icon, which will leave as empty, and the final one is your main class, and we're going to be creating this one shortly, but let's call it game.redball. Next attribute we are going to need is our micro edition profile. And this value always be MIDP-2.0. You can set it to MIDP 1.0 to target older devices. But yeah, 2.0 should target most of the available ones. Now, another one we need is the micro edition configuration. And this one is going to be CLDC 1.1. Finally, you can add a few more attributes related to app specific data, like the medlet name, which is again red ball, and we are also going to have the medlet version and the vendor. Let's keep the version as 0.1.0, and the vendor can be anything. I'll just name it home for now. Note that you might need additional attributes based on your target device, but this should be sufficient for most of our use cases. Now let's reload it. Once this is done, we can get started by creating our source code. You can create a new directory, and src, this is the one you're gonna need, and it will detect it as the main source. Now inside it would lie your package structure and your classes. Let's create a game package. Inside it, let's create a new Java class that will be called redball, as we have mentioned in our configuration. Now, this needs to extend the midlet class. To identify it as our entry point. Now, this would be coming in with a certain number of methods that we need to override. So these are the three standard methods. First the start app, then the pause app, and then destroy app. I think the names are quite intuitive. Start app is called when your application is starting up. Pause gets called anytime you pause it. And finally, destroy is called while you're closing the app. The Boolean parameter here would tell you whether to destroy it forcefully or not. So true means destroy by force, and we don't need to be using these for now, so we can keep them empty. And let's do the same here. So we'll be starting up with our start app class, and the first thing we need to build is our custom canvas, right? So let's create that. So we'll get a canvas class equals new canvas. Let's call this G to make it short, and here you can override your paint method and try to draw things up. So let's do a simple g.setColor. So this one would basically set the color of your current graphics context, and later on you can use the same color to draw things, right? So if you try to draw, you'd be seeing a bunch of pop-ups like draw string, draw line, rounded rectangle, images. So these are the primitives provided by the graphics API of the canvas. And what we're going to be drawing is, let's say we draw a rectangle, not a region. We'll draw a rectangle, and it's going to take in a starting point and an ending point. So let's call it 0, 0, 10, 10 for now. And for the color, let's pass in a hexadecimal value starting with 0x, and then we can make it, let's say, just red, right? So that'll be FF0000. So the first two is for R red, G green, and B blue, right? Now, to draw this canvas onto the screen, what you would need to do is to ask the display instance to show this canvas. So for that, we have to first get a display class, display.getDisplay for this midlet, and then you do set current to the canvas. Right. So we have something basic in here. Let's try to run this code. As always, you need to export your JDK or your local Java home to a JDK 8. So I have that command handy here. I will do that first, and then you can do a Gradle w red ball. So colon red ball means the first project name, and then you have the task name for it, which in our case is emulate. This will call the emulate task for the red ball project. Let's see what we get in this. Now, this is going to take a while. It's going to start a Gradle daemon, compile a few plugins, and then compile the app, generate the jar, then feed that into microemulator, and it might take a while for the first time, but once it's done compiling, it should pop up on the screen right here. Now you can click the start button and see you get a very tiny square in here. Not sure it's visible or not. Let's try to make this a larger square, right? So we'll close this app, and instead of 10 10, let's make it 100 100. And instead of drawing a rectangle, you can also create a fill rect function, which will create a filled rectangle that would be more visible. Let's try to emulate it again. Click start, and you can see a big red rectangle popping up, right? So before creating our diagram, let's clear the screen up to clear everything that is behind the scenes. So we will actually create a rectangle that is as large as the screen itself, so you can use the get width and get height APIs. Let's try this. So you click start, you see the screen is now filled with black. So that is the default color set. Let's try to set it to white. Set color to white, which is basically all Fs. You can see the entire screen is first cleared with white color, and then our square is drawn. Now, instead of using the fill rectangle, we can use a fill rounded rectangle. J2ME does not come with a fill circle method, and this is the closest one we've got, which works both ways because it is a rectangle as well as a circle. So the first thing, the first two inputs to here are the starting coordinates, and let's start it at 30 30 for example, and the next two basically the width and height of the rectangle, and I'll call it 40 for now. And you're gonna get two more inputs, which are basically your diameter of the arc, right? And to make it a circle, we would need it to be the same as the length of the side, the width and breadth. So let's keep it 40 as well, right? Now if we run it, there you have it. There is a round red ball. Looks good. Yeah. With that done, feel free to experiment around with these values, change it as per your liking. Just to make sure, let's try to draw the ball in blue. So we will make the last bit FF. And if we run this again, we should see a blue ball now. Feel free to experiment. Going back, we covered up all these steps, and finally, as you can see, we had the result as a red ball on a white canvas, right? So that's pretty much it for this video. I hope you enjoyed the content. Please like and share this video and subscribe to my channel to be notified of more upcoming videos like this. Thank you so much.